Hi everyone, and welcome to today's webinar, Querying with NoSQL, MongoDB versus Couchbase versus MySQL. Here are a few guidelines before we get started. All attendees are on mute, but you can submit any questions through the Q&A box, and we'll try to address them at the end of the hour. If you're having audio issues, make sure you're using a Chrome browser and try refreshing the page. The webinar recording will be sent to you in a follow-up email, and you can download the slides at any time in the resources folder below. With that, I'd like to introduce our speaker for today, Ben Lee, Principal Product Manager at Couchbase. Ben, over to you.
Thank you very much, Tanya. Welcome, everyone. As Tanya said, welcome to this webinar, which is about the topic of query comparison. And for this, we're actually going to be focusing on SQL, which is from MySQL, and also MongoDB query language, and also Couchbase. And to start with, let me show you basically So the webinar, we're going to be focusing on the report that was produced by Altoros late last year. And just a little bit of background about Altoros. Altoros is a company that specializes in providing services to companies to help Global 2000 organizations to obtain sustainable competitive advantage through the adoption of innovation of technology in general. They also offer methodology, training, and all that, and of course they are also a very work a lot with NoSQL database, which is why one of the reasons why we engage and collaborate with Altoros. So Altoros came out with this report. The idea is actually how for somebody for an organization that comes from a relational database background, how would they compare basically their the language of the standard SQL to that of Couchbase NoSQL or to that of Mongo? And they basically the approach they took is actually taking an approach of looking at an enterprise application perspective, and the kind of query that you would need in this kind of application, and they would then try to see how can those query can be implemented in, first of all, the standard MySQL as a reference point, and then compare that to NoSQL, which is like the Couchbase query language, and then that also MongoDB. They then the team at Altoros will then perform their own analysis and measure the effort and how difficult, and in terms of how or real world experience on how to use these three languages. They then provide some criteria to provide some rating and score applied to this a different scenario to reflect the effort and the skill set that you will need. And all of the work were done independently by Altoros, and they when they publish it, they also publish the all of their tests on GitHub, and that's the repository there showing with all the information of the data set that we will use for MySQL as well as Couchbase as well as MongoDB. So where do you go and get this kind of report? So let me quickly share you the screen here. So as you can see, basically, if you go to Couchbase, if you look at the results and under white paper, you will find that the report is also listed here in the Couchbase website as well. Likewise, Altoros themselves also published the report, and if you go to Altoros and also look for Couchbase, you will see the two reports that they, one of them is actually the report, the other one is just a blog. So that's where, so in case you want to know where to get to the report that they have published. So let's start with it. So basically, when we started out, we decided that because we want to present this from a perspective of an enterprise relational model application perspective. And the model that was suggested is actually we're using something called a CRM activity data model. And the benefit of this is actually, the way that, from our experience, we're seeing that, activity model is fundamental in a lot of different applications. Whether you're looking at sales, you're looking at services, you're looking at incentive compensation, whether you're building a supply chain, there's always some an element of tracking activity about what's going on when you deal with a customer. And the model that this is actually an example of that model, basically on the left here, the relational model. At the same time, basically the same model is actually translated to the document model base, which will be used by Couchbase and also MongoDB. So that's for that different test scenario. So before, a lot of these kind of the challenge that people come into NoSQL database and when they look at Couchbase or look in Mongo, the big difference here is actually in the data model itself. So before I go into the report, I just want to kind of talk a little bit about the data model. If you're looking at on the left-hand side, like the user information, the user table in relational model, user have experiences and skill set, and user also have a manager. So that's how it is typically represented in a relational model. User and manager relationship is represented by a self-referential key, and also the experience and skill set is modeled as a parent-child kind of table. Now on the right, which is like the document model, as you can see, the entire, all of the information is actually embedded in a single document model. The user and manager is also represented by a referential key. Of course, you do need to kind of join a lookup in order to find out who's the manager of a person. But the benefit here, the difference here is that instead of having to have a different document to represent the experience and skill set, all the information can be represented in one in an array within the document, which is like another kind of very powerful concept of kind of the document model. The second aspect here is, you look at the relational model I showed earlier, there's a lot of complexity in there, particularly around the concept of how they represent teams. For example, when in the sales team, when you have an account, you do have a number of people that work on that account, and that's typically represented by an account team object in relational model that's represented as an intersection table. Now, on the right hand side, in the model of document model, that kind of represents slightly different ways. Basically, of course, there are different ways to achieve that, but the way that this represents, for the purpose of this kind of a report, the team member themselves is actually represented as an array within the account. And then it has the key, the user ID that would allow you to join to the user document that I showed you earlier should you need for more information. So that's kind of the approach here is somewhat simplified because of the fact that because of it leverages the array element. So that's kind of the second area of difference that that most people coming from a relational model, myself included, that to understand how you can benefit the document model, and it's a very neat way of representing it instead of an intersection table in a relational model. The third area here is actually actually, this is actually probably the most powerful concept on the relation on the document model. If you look at activity itself, activity an activity can be of a type of an appointment on the task. And an activity can also have a number of users because the concept of a team there, and also an activity can if it's a meeting, you will have a lot of kind of association to contact. So that is how it is represented in the relational model. Not to mention that when an activity of type task, you can have a list of to-do lists. For example, there, what's next, and action item and all that kind of thing. So in the relational model, it is captured in a single table, like an activity. Of course, this is one approach. To capture in a single activity table, that table must have all the fields for appointment and task. And activity and appointment will have its own association to contact, and task would have its own association to the to-do list. And both of these type of activity can be associated to a team of users. If you look on the right-hand side, that model is somewhat simplified, because the fact that again the ability to have hierarchical data in the model means that activity can be and of course also the flexibility in the model. Activity can be of type appointment and task, and if it's of type appointment, it will have its own kind of field of appointment, and when the document is of type task, then it would have its own field of task. So you do not have to have like a superset of all the fields that to support both types. Each document can be basically can be different from one another, and that's like a key kind of advantage in the document model that relational model doesn't have. And with that, you can also join to user and account for the contact information. So as you can see, these are the three different areas that I find that the relational model actually is quite cumbersome because of the strict schema aspect of that. And one of the document model is a lot more flexible, allow you to store this kind of information in a very, very kind of a clean way, I think. Now let's go back to the report itself. When the team kind of started out the this particular report, they start asking about what are the different type of questions that people use in this application, in a standard activity management application. So if you go and look at any kind of services application out there, or whether in sales, whether in marketing, there's always a number of this type of query that people always use. And for example, I'm going to have a meeting with a customer next week. I want to find out all of the content that will be attending the meeting. Not only the content but the role, and so you need to kind of do some homework before attending the meeting. So every kind of user in the system would go in and actually run this kind of query very regularly to find out. So the same thing in sales. There is also a regional sales territory where a sales manager wants to find out all of the account, i.e. the customer assigned to his territory and account team member. And the third case is just a top 10 industry, but from all of the customers that you work with. So these are very common kind of queries that users do in this application. There's also other kind of query where you want to find, you do some analysis of, basically if you spend a lot of time in your sales team talking to the customer, you want to understand how much time have you spent talking to different customers. And so that in a way to find out the level of engagement, and also to understand whether you actually have not focused on too much on one customer or another. So these kind of reports are very useful there. Also, the fact that you want to see how the team have changed, the number activity within your team has changed month over month. Number 6 is about the skill set, understanding, for example, when people manage a particular sales region, they want to make sure that they have the right number of solution engineering or a different skill set involved, a sales team involved in order to manage that organization. Similarly, number 8 is actually an interesting one where instead of you floating down, you want to see whether we can use basically a Google API to sort of get a sentiment score on review information. So can the data, can the query language support that kind of thing? And lastly, it's around text search. Basically, how easy it is for the query to be able to search something that's a little bit complicated and vary depending on need, basically, which is typically like a text search or wildcard search. So these are the 9 scenarios that will be used. Now, I'm not going to go through all of them. I'm just going to pick up a couple of examples in the report that they have. And if you want more information, you can look at those reports that have been published, and we can see detail in terms of how they compare. So the first one here is the scenario 1. Prepare a list of customers to attend the meeting and their contact. But you can see there that basically, the result is shown in a graphical form just for visualization. But you look at the MySQL, for those of you who are familiar with relational database, you should see that it's fairly straightforward here. There's a query that goes against the activity table, and then it joins the account and contact, and also the participant to find out, basically all the activity of time appointment, between certain dates where perhaps this user-sensitive field is involved. So that's a typical kind of a standard relational query. On the right, basically, is the Couchbase NoSQL, and as you can see, that is very, it's very similar to that. And basically, it instead of doing, and you notice that instead of doing 3 joins, it's actually it's only doing 1 join, and to get the account information. And then what it does is actually doing a special cost unless because of the fact that the contact information is actually an array in the account document. What this unless does is actually it effectively flattens out to get all the contact information. And you notice that it doesn't join the participant to get because another special contract in construct in NoSQL whereby it performs a predicate directly on the array, and that's the any clause in the array. Again, in the Mongo query, it's doing something very similar. In fact, some people think that Mongo query is not a SQL, but in fact, it does everything in a similar way. Basically, first the matching, finding out, where for the participant is of certain value, and the start date and greater and less than, and also and then it would then join, which is like a lookup, which is like an outer join to the account, and also then it unwind, which is similar concept to the unless to get all of the contact information, and then finally it will project the result. So from the query, these 3 queries, I think this one being perhaps the simplest to follow, that you can see that they all perform the same function, and they were relatively, I would say, that's easy to follow. Now, when it starts to get a little bit more complicated, for example, in this scenario 5, and how the number of cells and related tasks have changed month over month during year 2018. And so basically, if you look at this, the MySQL, what it does actually is using a concept of the CTE function, a common table expression, and then it's also use the window function to doing that this kind of calculation. And the same thing applies with the Couchbase NoSQL as well. It actually supports the same thing, common table expression, and it also uses the window function, the lag window function to allow you to kind of look back, comparing what is the current number of sales activity this month versus next month. And on the right-hand side here, this is why you can start seeing that Mongo query is a little bit more involved in doing that, because to start, you actually, the query is broken down to two parts. First of all, you get the detail of 1 month first, and then from that, you would use that information to look back. Basically, I'm not an expert in Mongo query, but this is actually all of this. These are the information, the result that was written by the Altoros team, and they reckon this is the only way to achieve this is to break the query down into two components like this. So and it can it can do all the aggregation and all the lookup join as well. So it's very similar, but like I said, it's just written in different ways. And you can see that it is a little bit more involved on the Mongo query side than perhaps MySQL and NoSQL. Now, this example that I picked up here is scenario 6. The interesting part about this example is that the analysis on the sales team skill set, and because as you can notice that each user has a skill set and experiences, and so basically if you this query here is that when you're from somebody who the manager of a territory or sales team, try to understand if all the people within this organization, whether there are any kind of duplicate kind of skill set in this role. And the way to achieve that here is that with NoSQL, what it does is actually it's using a lot kind of an array function to answer this question. I mean, believe it or not, MySQL can't do this. SQL can't do this because in order to do this, what you need is actually like a list aggregation kind of functionality, which is not currently available in MySQL. Mongo can also can deliver this solution fairly well, and but again, it is a little bit more involved, but it can actually deliver the same kind of satisfy this kind of query in one single shot as well. So, like I said, what you're seeing here is that the general view is that the most is actually possible in these three languages, but some perhaps is a little bit more difficult to perhaps follow or read than the other. Scenario 8, which is actually something that we put in there, is the ability to see whether you can actually using your query language and call out to the Google API. And in this case, I take the example whereby, first of all, if you look at that, the subquery first, select basically what it does is actually it selected the name, the person, and the review, the hotel and the review, and then it passed that into a Google API call, in the form of my data. You pass that data into Google API. And what the Google API returns, that is return an array of result sets. So therefore, NoSQL can unless the result and display and select that information. So what we see on the right here is actually the output of the NoSQL query. So it actually shows you that basically for that particular hotel, what is the sentiment score for this review, and also by the magnitude as well. So this example here is actually trying to show the how whether the query language supports the ability for you to call out to external API, and NoSQL support that using the code statement. The Altoros team didn't find a way to achieve this with MongoDB. I don't know whether that is some other way, but they could not find a way to do that. And it was as you can see in the report. So, like I said, the purpose of this webinar here is allow to kind of try to highlight what's in the report. Even though this is a Couchbase webinar, but this is actually something that Altoros, as an independent company, did the analysis and provide their kind of impartial kind of view. They show us that basically some of the score did surprise us. And for example, they reckon that MySQL is actually fairly simple, I think from 1 to 10, between 8.3. And Nickel, they think that they're actually simpler than MySQL, which is because I suppose maybe from a document model perspective, it is actually they find it fairly simple to do that. And that's the rating they give for MongoDB. Readability also as well. I mean, basically, Nickel for the document models, they find that fairly easy to read, and also give like a 6.8. I think the flexibility part, again, they also score Nickel quite high there, and but the thing is, I think the skill set is probably an interesting point. I mean, you can go and find a lot of people who understand SQL, so therefore MySQL is always score highly when it comes to skills of availability. But Nickel, they reckon that it actually is still lagging behind because some of the constructs, although it's very similar to SQL, some of the constructs to allow you to manipulate kind of hierarchical data in a way can requires a little bit training. That's why we get it 6.7. And also they also recognize that MongoDB is very popular, but nevertheless it's actually kind of the skill set is not that widely available comparing to SQL. So the overall score, I mean, they gave in that report is actually very good for SQL, and for most to understand that, but and also very decent score for Couchbase Nickel as well. The one part that they also, I mean, when you look at the report, is the number of lines of code. And basically, you can see there the chart showing MySQL being blue, and Mongo and kind of green. And clearly, writing code in SQL, I'm used to, and now and Nickel, it's very, very expressive, and you don't need that many lines of code comparing to if you were to write a query in Mongo, where you can see that consistently Mongo requires a far higher number of lines of code to satisfy this query. And it's interesting, scenario 7 here. Basically, somehow the team end up having to write almost like a 347 lines of code to answer that question. So if you look at let's look at this query here, query 7. The query to review all the presentation that we have conducted with customer in calendar year 19 Q4. The query shows the time we spent for each meeting, the running sum, and the percentage of time for the meeting over the total time we spent. So this is more of like a kind of a running total, running sum kind of query. And Couchbase Nickel support what we the concept of I mentioned here that in 6.5 it support window function, and that's the function that allows you to kind of effectively aggregate something, but the metric by a particular kind of a field. So that's how you get the running total and also the percentage of time and also the rank. So these are very common statistical kind of query that people use all the time. Although sometimes basically, I think even for SQL users, sometimes you may not be using that because a lot of times people just write simple query and perhaps rely on Excel to do the rest. And Windows function is, it can do the whole thing in one go. And when this actually came out in ANSI SQL standard I believe in 2003, so it's been around for a long time. And NoSQL support that kind of completely as well. The MongoDB code here is actually, the example here that they show is actually has 347 lines in order to be able to kind of produce the result. So you guys can see, basically we're not just here to say that how good or great NoSQL is, but you can see that the asset to if you were using Mongo, some of the simple query like in the first scenario, second scenario is okay, but when it comes to more complex enterprise level type of application queries, it can be very complicated to run. Actually another dimension that they kind of in the report here is the concept of number of client to server trick, because SQL and NoSQL, MySQL and NoSQL basically it's a query language, so you only write one query and you give it to the server, and the server will process and return the result. So you can see that all of the scenarios, MySQL and NoSQL, that it only requires one single trick, i.e. you submit to the server and that's it, you get the result back. But anything that's a little bit more complicated, then you will have to break the query down to multiple components. So like scenario 4 here requires 3 different tricks. By that, I think what it means there is actually you actually have, it's similar to the concept of subquery. You write one subquery first to get the result back, and then you pass the result of the first subquery into the second query, and so forth. And that's what happened in scenario 4 and 5. And as I mentioned, showed you earlier, in scenario 7, it requires 5 different, maybe 4 different subquery and 1 main query in order to satisfy the result. Again, this report only focuses on the query kind of comparison. It's not focusing on performance and anything like that. But as you can see, basically, if you have the right queries that doing multiple tricks to the server, it would be very hard to to ensure the kind of performance because not only that you need a powerful server, but your client needs to be able to hold a lot of interim data as you pass back to the server. And I think so that's kind of these are like the highlight of the kind of the report of the Altoros report. And in there, they also put they're very good at providing a summary of their key findings. And I put it basically, when it comes to declarative versus procedural, SQL and NoSQL is declarative. For us, who've been working with SQL and before, it's a declarative kind of language. You declare what you want, and then the server takes care of the rest, allowing the user to specify the outcome directly. And in the declarative, it relies on the database optimization code to know best how to kind of process your query. MongoDB, on the other hand, basically it's procedural. So it requires you to explicitly set the order of the operation. So I suppose this is actually to reflect some of the query why we have to break it down to multiple components. You actually have to make sure that you start with the sub-query first and then get the result and pass on to the subsequent query. And that's what it means by that. You need to do things in a particular order to get the result. Standard versus proprietary. So SQL is a well-established standard, and NoSQL extends SQL to handle JSON documents. In general, SQL skill is actually easier to find. A lot of our the feedback we get from people coming using Couchbase is that basically when they start writing NoSQL, they realize how similar it is to and how easy it is to manipulate that the kind of JSON document and with their background of SQL. MongoDB it is a proprietary language, and in my view, it's actually quite popular and because it's very intuitive, but it's only with simple queries. And it can get complicated when you need to join an application. And for those of us who, for those applications that do not need to do any join and complex, then perhaps that's okay. I mean, here in this example, we're seeing a lot of customers are starting to move to NoSQL to develop a complex enterprise application. And a lot of these enterprise applications, the data model is not something that you can easily denormalize into a single document. So you still got stuck with a level of join that will be needed, and that would be very difficult to achieve with Mongo. The number of times to solve a trick, this is actually a big issue, and we didn't realize until after they spent time developing this query, we find that basically for SQL and NoSQL, again, it's actually just a single trick. But Mongo, the fact that once you start breaking things down into multiple components, it can get very complicated, and I don't know how be able to manage like a query that's like 300 plus line of code. That would be I would say that is not suitable for that kind of query at all. And it is more complex than to maintain. Of course, also performance and the resource required in the application as well. The one last point here is join. And when we work with Altoros, who's been working, who they have excellent skill in NoSQL database, and they're very good at Mongo, and they realize that basically for this type of application, like I mentioned, that doesn't require up join, then that's fine. But there's more and more use case that data model will have some element of normalization there, and therefore it has to be able to join. And with SQL and likewise NoSQL, basically there's no issue around join. NoSQL support join. It's a comprehensive join. That's anti-join, level to join, right to join, basically, and all of that are probably the SQL standard. And it doesn't matter whether you join from the documents from one node to another. But that's not true with Mongo. Mongo supports lookup, which is like a left-out join, but that's only if actually on unsharp node only. So this limitation can be fairly difficult to overcome because in the case of Altoros, how they do that, they end up having to avoid doing the join by doing client-side coding, i.e. they subquery and then get the result back to the client and do the join. But as you can see, that limitation is actually quite not very suitable for kind of complex enterprise level that application that still has an element of relational normalization. So that's pretty much basically what I want to talk about in terms of the query kind of comparison. But as you can, Couchbase is support of NoSQL is language that will deliver a NoSQL database built on a foundation of developers' agility, performance, scale, and manageability, and security and high availability as well at every product layer. And that's something that I think the database we have actually is, as you can see, some of the use case here is at LinkedIn. LinkedIn, when you use it as single view of something like over 600 million accounts, all in-memory storage in LinkedIn data center is done by Couchbase. And the same thing, if if those of you in Europe, Tesco store and update product data for over 10 million items and scale up to support like 35,000 requests per second. Amadeus is a travel platform, 8 million off per second in under 2.5 milliseconds, response time. We also like Comcast, single view over 100,000 internal users accessing all of their documents. So, and including United, which is like another big use of Couchbase. They use their Couchbase for their application provider to make sure that you kind of arrive safely and services millions of travelers every year. So again, we are kind of a leader across all range of industry are using Couchbase today. Kind of the most critical application. Our customer, including industry leader like Amazon, as they say, AT&T, Baker Dixon Company, California, and you name it, Marriott, so Wells Fargo. So these are all the different companies that are kind of using our database today. Again, not because of the different the power and the high availability aspect of the NoSQL database, which is, like I mentioned, that we have, but also the fact that, like I said, mentioned to you, how easy it is to query the database, especially if you come from a kind of a SQL relational background. It would be very simple for you to kind of learn SQL as well. I just want to do a quick screen share of the data that, as I mentioned to you in one of the data model aspects, if you notice that this is actually the document, I've loaded that data set onto one of our Couchbase instances. And the part that I wanted to show you is the flexible model, document model. Here, I'm looking at one of the activity, and the activity is of type task. And as you can see, for an activity of type task, I have a list of to-do list, which is like basically what I was showing earlier in terms of the flexible concept of how the document model can have different kind of content depending on type. So on task, for an activity of type task, you can actually have a list of to-do list as well as a list of participants. However, if you look at a different activity again, but this time is of type appointment, you can see that instead of to-do list, the document actually have an array of contacts, which is the account people, the contact from the customer who attended the activity, and also the array of participants as well. Again, that's just to show you basically the flexible model of the JSON document there. So I think that's a little bit early, but that's kind of the end of my presentation. So if you have any questions, I'd be happy to answer.
Yeah, thanks, Ben. We do have a few questions in here. The first one is, the Mongo BI connector can parse SQL into Mongo's query language. How does it compare?
Right, yeah. The Mongo BI connector was implemented on actually, I believe, using a MySQL kind of base. And the joining there, I believe, even though you can use join, if your database is actually like it doesn't kind of resolve the problem that if your node is shard, So if it, on Sharp and Node, then it would work. So you're right, you can actually using join there, but if you're not on Sharp, then you would probably run into the same issue. And the other BI connector that Mongo uses is actually a very lightweight. You're running on basically on the client side that you can do. So I'm pretty sure that it doesn't resolve all the sharpest issue that Mongo has.
All right, thanks. Next question is there a performance tuning tool for Couchbase?
Yes, performance is actually an area like an A3 database. Whether you look at MySQL using Oracle SQL Server, those have very comprehensive performance tuning. And with Couchbase 6.5, we deliver Index Advisor. So basically, this is actually the first step towards a comprehensive performance tuning tool. For the first step, the advice that we provide is advice on index. So you can use this in 6.5 today. If you download it and any query you get to it will actually advise you the appropriate index for that. In addition to that, there's actually something that we did just a couple of weeks ago. If you go to Index Advisor at Couchbase, it actually will provide effectively like an Index Advisor as a service. You can go to our Couchbase Index Advisor .couchbase.com. You provide your unique query, it will recommend the index immediately. So you don't even have to have Couchbase running to benefit from that.
All right. Next question is, does Nickel support commit and rollback?
Yeah. So basically, commit that transaction, Couchbase 6.5 support transaction, and you can do that using our SDK. So the SDK that we provide 6.5 allow you to kind of start and perform your operation and then commit at the end. With Nickel, we are working on providing similar services in the future release. But right now, from the Couchbase does have support for transactions, but we just have to use our SDK instead of Nickel.
All right. Last question here: is Nickel an extension of SQL++?
Yes, yeah. As I mentioned, Nickel is definitely an extension of SQL, not only because purely because the fact that JSON, Nickel is designed to manipulate JSON document, and JSON document is not as flat like a relational table, rows and tables. So therefore, you need to kind of we introduce additional functions like array and object functions that allow you to manipulate that. So it's quite extensive. I would say that it is an extension of SQL, although there are features that we continue to kind of enhance our product. For example, in 6.5, we just improve enhance Nickel join to the ability to not only join to but join to subquery. So you join to an expression. So that's something that ANSI SQL support, and we added that to 6.5. Yeah, so it is an extension.
All right, great. Those are all the questions we have today. So thank you, Ben, for that presentation, and thanks everybody for joining today's webinar. You can download the slides in the green folder icon in the bottom of your screen. Please also take a few minutes to answer the survey that will pop up so we can make our webinars better for you. Thanks again and have a great day.
Thank you, everyone.